Again, good morning, everyone. Good morning, grade 9. We
Morning, sir.
the continuation of the lesson proper, which is the climate, right? Let me share my screen again. Can you see my shared screen now?
Yes, sir.
Okay. Let's move now to altitude. Altitude is the height above sea level. Okay. The higher the altitude is, the colder the climate. Air is colder on top of the mountain since less air can absorb heat. As you go up into the mountain, you need to prepare for colder and less air. For every 1,000 meters, the temperature drops by 6.5 degrees centigrade or Celsius. Air pressure also contributes to the decreases or decrease in temperature. As air pressure decreases, the temperature also decreases. Alright? Vegetation. By the way, for altitude, it just saying that the higher you are, the colder the climate is, or the colder the air, since there is the air there cannot absorb heat, or there's a less absorption of heat. Again, for every 1,000 meters, the temperature there drops by 6.5, so it's more colder when you go higher, just like the Mount Everest. Okay, air pressure also contributes to the decrease of temperature. So this is now the ratio. As air pressure decreases, the temperature also decreases. Okay. Vegetation. Vegetation affects temperature and the
Excuse
amount
me, sir.
of vegetation. Yes, MD.
What's the difference between altitude and the latitude?
Altitude is the height, okay, above sea level. Latitude is from north and south of the earth. That's the latitude. Again, latitude is from north and south. Okay, that's the latitude. That's the marking between north and south.
Ah, okay, sir.
Altitude is the height above sea level. Okay, just like your sky, the altitude. Just like when you're riding a plane, the higher the altitude, it becomes more colder. Vegetation. Vegetation affects temperature and amount of precipitation, yes, in the region, correct. Vegetation can affect the temperature due to its capability to absorb and release energy from the sun. Remember that your plants are what? They are producers or the autotrophs. They can perform photosynthesis, therefore, they can actually absorb the heat from the sun. When plants release water vapor during transpiration, it adds up to the formation of clouds and later to precipitation. This is the reason why there are a lot of fog. Remember the fog, MD and Margie?
Yes,
This is
sir.
the reason why the more plants you have, the more possibility of having fog because of the suspended water vapor um, in the environment during transpiration. Remember that your plants transpire, leaving water vapor in the leaves and in the environment. Okay, and later it will contribute to the formation of clouds and later precipitation or rain. Precipitation is the other term for rain. World climates. Do you have any questions so far? Do you have any questions so
Sir, fog is concern of cold.
Yes, there are two kinds of
No, sir.
vapor actually. Um, we have fog and smog. Smog is the polluted one.
Smoke.
Um, when the water vapor or when the air suspended particles in the air or water vapor becomes polluted, it will become smog. It will carry some dust particles as a nucleus. And the second one
Excuse
is
me,
smog.
sir.
Yes, MD.
What's the difference between mist and fog?
Come again, Margie. You're laggy.
What's the difference between mist and fog?
Waste. Come again. Wastes.
Mist,
Mist.
mist, mist.
Mists. When you
Is
say
it not more?
artificially, you're making a water vapor. It's a mist. You're transforming um, water into uh, water vapor artificially. That's a mist. Imo bang convert ang
Your man-made, sir?
na into uh, into a water vapor. Okay, it's really important also to create mists, especially those plants that are air plants. Are you familiar with the air plants? Just like your orchids. Orchids usually you cannot actually pour water in the orchids because it will not actually absorb the orchids. They need they need mists and water vapor. So misting is the process of converting water into water vapor, into its vapor form, in order for other plants to absorb the said water. Any other questions so far?
No, sir.
How about Margie? Margie isn't around again.
Yes, internet problem, sir.
Okay, so let's move forward. Okay, let's move forward. Again, when plant release water vapor during transpiration, it adds up to the formation of clouds and later precipitation. World climates. Margie, do you have any questions so far? Additional question? Follow-up questions? Okay. Climates are classified based on environmental conditions, such as the temperature, humidity, and amount of precipitation, and the natural
No.
vegetation that exists in the area for a long time. The Greek philosopher Aristotle was the first to classify climates based on regions from the equator. Okay, he actually based it on the equatorial line. His division of latitude are still known. They are the equator, Tropic of Cancer, the Arctic and the Antarctic circles. Tropic of Cancer and Capricorn, the Arctic and the Antarctic circles. So this is the classification of Aristotle. Okay, the Tropic of Cancer and Tropic of Capricorn. We are actually in the Tropic of Cancer. Next to the Tropic of Cancer, we have the temperate zone, which has a lot of seasons. We have summer, winter, uh, fall, and the other one that's four seasons. They actually have four seasons in the temperate zone, and it's different when you go to the Arctic and Antarctic zones. So this is based on Aristotle's climatic classification. Modern classification was brought by Alexander von Humboldt, who drew a global map with the mean temperatures, and Vladimir Koppen, who refined Humboldt's map and added seasonal temperature range. The Koppen climate classification. Okay, the Koppen climate classification system classifies climates based on the temperature and the amount of precipitation in a region. Okay, it was developed by Vladimir Peter Koppen It was brought about his works on the improvements of Humboldt's map in 1884. Wait. As a botanist, remember that this Koppen is a botanist. He based his classification for climates was patterned, or he based his classification for climates patterned after Carl Linnaeus' classification for plants and Luke Howard's classification on clouds. So, this is now a combination of the works of Linnaeus and Howard. Okay? Koppen later improved his classification in 1918 and in 1936 with Rudolf Geiger. Sometimes they pronounce this Jigger, sometimes Geiger. The system is based on the mean monthly temperature and the amount of precipitation in a region. It has five major classifications, namely the equatorial climate, the arid and dry climate, the warm temperate climate, the snow climate, and the polar climate. Each major classification is represented by letters A, B, C, D, and E. The subclassifications are represented by additional letters. The second letter is for precipitation, while the third letter is for temperature. All major classifications are defined by temperature except for type B climate. So, the examples are this. This is the Köppen, okay? Köppen classification, A, B, C, and D. Letter code, again, this actually gives us an information about the temperature, the climatic condition, the type, and its characteristic. Okay. Do you have any questions so far?
No, sir.
Okay. Let's have an activity by next meeting and continue the discussion by next meeting, hopefully, with climate change. Now, what are the
Okay, sir.
things that actually affects climate change and how this also affects us in our daily lives, right? How about plants? How about animals? How do they are affected with climate change? And if this persists,
Excuse me.
some animals. Yes, MD.
Can you post this on the LMS so I can go
Yes,
back?
I will post this in the
If
LMS.
ever.
Yes, you can always go
Thank
back
you,
to the
sir.
lesson about what we had discussed. Right? Any other question, Margie, MD?
No, sir.
No, sir.
I think that will be all for today, class. Let's have the activity again by next meeting, hopefully, and continue the discussion by next meeting with the climate change. Thank you for your participation, MD and Margie. Have a nice day, grade 9. Goodbye.
Thank you, sir.